Let's zoom in on one of the body's most overworked, underappreciated, and quietly rebellious organs, the liver. This big, squishy chemical factory takes care of everything from detoxifying booze to balancing blood sugar, processing fats, storing vitamins, and producing bile. It's the kind of multitasker that could run an entire household if it weren't stuck in your abdomen. But like any hardworking organ, the liver gets tired, especially as we age. And sometimes, it doesn't just get tired. It gets senescent. Now, when we talk about liver problems and aging, we often hear about fatty liver disease, a condition that's skyrocketed globally alongside obesity, poor diets, and sedentary lifestyles. Non-alcoholic fatty liver disease, NAFLD, and its more ominous cousin, non-alcoholic steatohepatitis, NASH, are no longer just fat person problems. They're age-related, inflammatory, and often quietly progressing toward fibrosis, cirrhosis, and liver failure, even in people who don't drink a drop. What's behind the metabolic mayhem? Increasingly, researchers are pointing to senescent hepatocytes as part of the problem. Hepatocytes are the liver's main working cells. They process nutrients, make proteins, detoxify drugs. But under chronic stress, high fat, high sugar, oxidative stress, stress, mitochondrial dysfunction, you name it, they can enter a state of senescence. And once they do, they don't go down quietly. They stop dividing and start broadcasting the infamous SASP, senescence-associated secretory phenotype, a noisy cocktail of cytokines, chemokines, and matrix metalloproteinases that scream inflammation to the immune system and surrounding tissue. But not all senescent hepatocytes are identical. This is where things get interesting. Using tools like single-cell RNA sequencing, spatial transcriptomics, and high-resolution imaging, scientists are beginning to classify subtypes of senescent hepatocytes in fatty liver disease. Some appear to be profibrotic. They signal for scar tissue. Others are metabolically dysfunctional, blocking insulin signaling and lipid oxidation. A third group might act more as immune magnets, summoning macrophages and neutrophils into the liver for a cytokine-fueled rave that ends with tissue damage. And just to complicate things further, a few senescent hepatocytes may even play a protective role, preventing damaged cells from turning cancerous by hitting the cellular pause button. It's a messy scene, and exactly the kind of biological mess that invites a bold question. Can we clean it up with senolytics? Senolytics are drugs designed to selectively kill senescent cells, ideally without hurting their healthy neighbors. Think of them as molecular bouncers for the worst-behaved guests at the cellular party. In the context of fatty liver disease, the idea is to flush out the most toxic hepatocyte subtypes, the ones causing inflammation, fibrosis, and insulin resistance, while preserving any potentially protective ones. Early animal studies say, maybe. In mouse models of diet-induced fatty liver disease, senolytics like dasatinib and quercetin have been shown to reduce liver fat accumulation, improve insulin sensitivity, and decrease markers of fibrosis. Some even reverse early signs of NASH. It's like giving the liver a chemical spring cleaning, sweeping out dysfunctional cells and allowing healthier ones to repopulate. But, and this is a big but, the challenge is precision. You don't want to nuke all senescent cells in the liver. Some are likely just collateral damage. Others may be holding the line against oncogenic transformation. The future, therefore, lies in refining our tools, using machine learning to identify harmful senescent hepatocyte subtypes based on their gene expression, protein profiles, and spatial behavior. AI could help differentiate the pro-inflammatory saboteurs from the cautiously senescent sentinels and guide therapy accordingly. This approach would also allow for personalized senolytic strategies. Your liver may not age like someone else's. Maybe your hepatocytes skew toward the fibrotic subtype, while someone else has more metabolic dysfunction. In the long term, you could imagine liver biopsies or even non-invasive imaging being paired with senescence profiling and patients receiving customized cocktails of senolytic agents or SASP-blocking drugs tuned to their specific cellular landscape. And there's another exciting angle: regenerative capacity. Some research suggests that clearing senescent hepatocytes may not just reduce inflammation, but actually stimulate liver regeneration. By removing the cellular deadweight, the tissue environment becomes more permissive for stem cell activity and repair. It's like cutting out dead wood so the tree can grow again. Of course, we're still in the early days. Most human trials are just beginning, and the liver, being central to drug metabolism, is a delicate place to start experimenting with cell-killing compounds. But the promise is real. If we can crack the code of hepatic senescence subtypes and selectively erase the troublemakers, we may finally have a way to reverse fatty liver disease, not just manage it. So yes, your liver ages. But with Senolytics, precision tools, and some AI-assisted detective work, we may soon be able to give it a second chance. Not by replacing it, but by clearing out the noise so it can do what it does best. Quietly, efficiently, and without complaint, keeping the rest of your body running.